Alright, so in this video we're going to talk about functional groups, and what I hope to accomplish eventually is to help you to understand how functional groups affect reactivity. Alright, and so let's go to the next slide. Let's talk about what a functional group is. Functional groups are the parts of molecules that give them their function or their functionality. So it's just a group of atoms that behave in a particular way. They all react in certain ways depending on what the functional group is. They have a defined role within a molecule, and if they're in the same family, let's say for instance carbonyl functional groups, then they're probably going to behave in a similar fashion. And so functional groups really dictate reactivity. They make compounds react the way that they do. And so let's look at we're going to look at some functional groups, but what you'll learn from this video is how to identify, draw different functional groups, and common places where particular functional groups are found. Alright, so at the end of each slide, or at the end of each type of functional group, I'll have a blank slide, and we'll work on drawing some of the functional groups. Alright, so some of your common functional groups are alkanes. We'll talk about those. Alkenes and alkynes, those are very simple to talk about and discuss. Esters and acids, ketones and esters, amines and amides, and alcohols and ethers. All of these we're going to discuss. The esters, acids, ketones, aldehydes, that should be aldehydes, not esters, amines and amides, alcohols and ethers are all going to be separate videos. Alright, so let's talk about alkanes. Alkanes are carbon chains consisting of all single bonds. Alright, alkanes are what we call saturated hydrogen. So hydrogen occupies all of the space on carbon unless it's bonded to another carbon. Alright, and these are just some typical alkanes. Octane, when you go to the gas pump, there's 87, there's 89, there's 93. Octane, right? This is octane. You've already done this when you had to write out the skeletal form for octane from the list that I gave you. But the actual stuff that's in your gasoline is here. 2,2,4 trimethylpentane. It's still 8 carbons. It's 18 hydrogens, but the structure is different. So these two compounds are what we call isomers, constitutional isomers. They have the same formula but a different structure. So you should definitely jot that down. Constitutional isomers. Both of these have the formula C8H18. However, they're two different compounds. Alright, so alkanes can actually be substituted with groups on the backbone. Remember, alkanes are carbon chains that only contain carbon and hydrogen. If you substitute an alkane, meaning if you put some other group on the backbone, if that group is a halogen, then the alkane is no longer just a simple alkane. It becomes what we call an alkyl halide. Alkyl refers to any group that contains only carbon. So an alkyl halide contains carbon and a halogen, or halogens, because you can have multiple halogens attached to the backbone. If the groups are carbon attached to the backbone, then the alkanes become what we call branched alkanes. So let's look at a couple of examples. So right here, what you see is hexane, right? And you see the backbone here. This is just a skeletal form. Let's make it more plain. So for hexane, you have 6 carbons in the structure, and these 6 carbons make up the backbone, right? Because it's an alkane, remember that each carbon in that backbone is bonded to hydrogen, right? So this carbon has 3 hydrogens attached to it. This one has 3 hydrogens, and all of the other carbons have 2 hydrogens. Let's look over here. Now we have 3-chlorohexane. Alright, so now we have an alkane with the chlorine attached to the backbone. So remember, this is no longer just a simple alkane. Now that we have a halogen here, it's an alkyl halide. Where does this number 3 come from? Right? Why do we have the number 3 in here? Well, we start counting from the end that the chlorine is closest to. So this is 1, that's 2, and then this is 3. Excuse my handwriting, that's kind of sloppy, but you'll get the point. Alright, so this is 1, 2, and 3, and the chlorine just happens to be on carbon number 3. Alright, remember, if we put a carbon group on the backbone, this now it becomes a branched alkane, and this particular alkane is 3-methylhexane. Right, again, this is 1, this is 2, and where the CH3 group is, that's 3. So you start counting from the end, or start counting from the end that's closest to this branch point. All right, we'll talk more about that later. I just wanted to introduce you to nomenclature and alkanes. All right, so another functional group that falls in this family are alkenes. And these are again carbon containing compounds that contain double bonds. Right, so you have at least one double bond somewhere in that compound in order for it to be called an alkene. Alright, this particular compound is ethylene. This is chloroethylene, which is the base compound for PVC pipe, vinyl chloride. Right, this is the base compound for PVC. The white pipes that you see under your sink, especially in newer homes. This is tetrafluoroethylene, tetra meaning 4 fluorines, 1, 2, 3, 4, and then the fluoro for fluorine, and then ethylene. All of your alkenes have the same ending, E-N-E. That tells you, when you see that ending, that tells you that there's a double bond present. So here's my double bond, and tetrafluoroethylene is the base compound for Teflon, which if you eat eggs, or if you have a little bit of money in the bank, you can go buy some nice non-stick pans and pots, and they're coated with this with Teflon, which is made from this compound. All right. Another carbon functional group is alkynes. Notice the YNE ending on the name. That ending signifies that there's a triple bond somewhere in that compound. Right, so an alkyne is a carbon, has some carbon chain, but there's at least one triple bond in the compound. All right, so here's some products down here, because acetylene, which is this compound, is used to make polyacetylene, which is a conducting material that can be used in microelectronics. Of course, this is an old iPad. They're much smaller and nicer than this now. And these are just a couple of smartphones. I feel embarrassed because I used to have this Palm Central smartphone. That's going to conclude alkanes, alkenes, and alkynes, and we'll move on to esters and acids in the next video. So go make sure you watch the next video. All right, peace.